Okay, yeah. We covered quite a few word problems. So let's talk about those four types. And yes, there'll probably be one at least of each type. What we did the mixture problems. We did the interest ones, the motion, distance, rate, and time, however you want to describe them. And then we did the angle, ones with the angles. So yeah, I would suspect one of each of those will be showing up come test time there. Yeah, on the mixture, let's say a chemist needs a 40% mixture. If she mixes 5 liters of 8% solution with some 50%, how much 50% is needed? To get the 40%, in other words. Okay. Well, the way we arranged this, the picture that I drew anyway, was, well, we're mixing 2 quantities together, and then we get the mixture, the bigger bucket there. All right, which two are we adding together, so to speak? Well, the 2 are adding are the 8 and the 50, right? The 8% and the 50%. Those are the 2 we're adding. And then over here we put the mixture. Well, the mixture we want is 40%, right? Okay, well, to get our equation all set up, what else did we put down below? We put the amounts, okay? So I want the amount of each. In this case, I've got amount-wise, do I know how much 8% I have? 5 liters. Do I know how much 50% I have? No, so I call it X. The mixture then, well, if I'm adding 5 liters and X liters together, that gives me 5 plus X liters in my mixture. Yeah, and that sets up the equation, doesn't it? I've got multiply each percent times amount, 8% times 5, or in decimal 8%, 0.08, move it 2 places back. So I multiply that 0.08 times the 5. The 50%, 1, 2, so that'd be 0.50 times X equals then 0.40 times 5 plus X. Gives us a nice equation to solve. 0.08 times 5, what do you got there? 0.4? 0.4. 0.50x. Just leave that like that. Distribute here. The 0.40 times 5, that'd be 2. And then 0.40 times x is 0.40x. Get the x terms on one side, so I'm going to subtract my 0.40x and subtract my 0.4 to get the constants on the other side. So that's 0.10x equals 1.6. So if I divide off the negative 0.10, that gives me a nice little x there of 16 liters. So I need quite a bit of the 50% there. Is that okay? All right, on the mixture, ones. Let me see if I can get one here. Yeah, that'll be good. Okay. All right. Everybody got that one? For an interest one, let's do this. Let's say Sherry invests some money at 5%. And and $100 more than that, then twice that amount at 4%. Sherry invests some money at 5%, $100 more than twice that amount at 4%. If the total annual interest is $264, how much is at each rate? Okay, well, we arranged these so we had a nice little table. Because we've got two accounts, so let's put the information for each one of those, and I call it the pry table, but you don't have to call it that. But yeah, I'm going to put the principal rate and then the interest on the end. Because, why do I do that? Well, principal in 1 year, simple interest. The interest in 1 year, if you've got simple interest, is principal times rate. So I'm going to multiply the principal times the rate, and that's going to be the third column over there. All right. Principal just means the amount in the account. How much do I have in account 1? Don't know. That's what I'm looking for. The rate is 5%, so that's 0.05, 2 places back. Move that decimal. Now account 2, the principal, well, all I know about it, I don't know it either, but I know it's $100 more than twice the amount of account 1. 2x plus 100, wouldn't it? Could write that way. And it's 4% rate, so 0.04. All right, so like I said, then for the third column over there, I'll do the interest, do the principal times the rate. So I take x times 0.05. Well, let's write that 0.05x. Account 2, I take the principal times the rate, so that's 0.04 times 2x plus 100. Then I can use that. Well, the way I use that is I know that the total interest, if I add the two interests together, it's 264. So if I take these two interests and add them together, I should get 264, right? Yeah, so just add those two expressions. Gives me a nice equation there to solve, linear. Distribute the 0.04, so I have 0.05x plus 0.08x plus, see, 0.04 times 100 is 4, isn't it? Do you believe? Like terms, 0.13x plus 4 equals 264. Subtract 4. So 0.13x equals 260 divided by 0.13. I get x is 2,000 there. Is that right? Be sure to answer the question here. How much is at each rate? That is the 5% at the 5% rate. At 4%, we've got 2x plus 100. So now since we know x is 2,000, 2 times 2,000 plus 100 would be 4,100, wouldn't it? Is this okay? Those, of course, are dollars. Sound all right? Okay. All right, yeah. The other another type we had was the motion ones. Distance, rate, time. Yeah, if we say something like Bob leaves at 4 o'clock, headed east at 45 miles per hour. Janice let's say Janice leaves at 4:45, headed west at 55 miles per hour. How long will it be before they are, or how long will it be when they are, still don't like that, how long will it, say it this way, how long will it take them to be, I'll say it right here in a second, .300 miles apart. Okay, well, we did another table there. Rate, time, and distance, RTD. Bob and Janice. Yeah, we want to fill in the rate, the time, and then the distance in this case. Be the last one. The rate of Bob is 45, and the time is unknown, so let's just call that X. Janice is 55. Time is, well, we don't know that either. However, it's not the same amount, so it's not X, but it is related to it. She's leaving at 4:45, 45 minutes later. So her time is less time. It's 45 minutes less. However, since we're talking miles per hour, the time is in hours. I need to know what about minutes, 45 minutes in hour form. 0.75, how can we get that? Yeah, we take 45 divided by 60, right? 60 minutes. So if we do that, it's 0.75, 3/4, however you want to say it there. One way we could do that. Now the distance, we do that over here because then with those rates and times, distance is rate times time, just multiply those together. 45x, 55 times x minus 0.75. All right, now, might point out here then, yeah, sometimes we added those. Sometimes we set them equal. But again, remember these are distances, and in this case I have the total distance. So I want to add those. When do I set them equal? Well, I would set them equal if I want their distances to be equal, right? If I'm saying Janice is going to catch Bob or something like that, the distances would be equal. But here, I want the total mileage to be 300, so I add these two together. And that equals the 300. Solve that one, right? Of course, that means distribute your 55. 55x, and then 55 times 0.75. 41.25. That's what I get. Does that sound right? 45x and 55x is 100x. Subtract, add the 41.25. So 100x equals 341.25. Divide by 100. And x is 3.41 or thereabouts hours. And, if we wanted that, that would suffice here. If I wanted that in a minute format, I would multiply by 60, right? Just say 3.41 times 60. That'll be the minutes there. So 204.6, something like that. So, all right. Okay. Question or concern about any of that? Okay. Yeah, the angle ones, we looked at a couple of different types. Sometimes the angles equal 90. Sometimes they could equal 180. Different things. Yeah, we know if we've got a right angle, what does that equal? 90. If we've got the sum of the angles of a triangle, that's 180. So those are the two basic ones that we covered anyway. So remember those two things, and yeah, you just add the angles up and get 90 or 180 depending on the scenario there. I don't have one prepared for that, so refer back. I think I have one on the review sheet though. So, all right.